Copilot Podcasts. An AI just decided whether you get a loan, a hospital bed, or even a job interview. And here's the part that should stop you cold. Nobody, not even the engineers who built it, can fully explain why it made that call. Today, we're pulling back the curtain on the black box problem in AI, what it actually is, why it's getting more serious by the day, and what researchers and regulators are scrambling to do about it. By the end of this episode, you'll understand how these systems make decisions, why transparency is so hard to achieve, and what's being done to fix it. And to help us get into all of it, I've got someone who's been deep in this space. The black box problem is one of those things that sounds abstract until it lands on your doorstep. And right now, it's landing on a lot of doorsteps.
Okay, so let's start from the ground up. When people say black box AI, what does that actually mean? Like, in plain terms.
So the simplest way to think about it, and IBM puts it really well, is that a black box AI is a system where you can see what goes in and you can see what comes out, but what happens in between is a complete mystery. You feed it a resume, it spits out an assessment. You submit a loan application, it returns a decision. But the actual reasoning, hidden.
And that's not just hidden from us regular people, it's hidden from the people who built it too?
Exactly, and that's the part that really gets people. IBM specifically notes that many of the most advanced models today, including large language models like ChatGPT and Meta's Llama, are black box AIs that were trained on massive datasets through complex deep learning processes, and even their own creators do not fully understand how they work.
That's kind of wild when you say it out loud. The people who built the thing don't know how it works.
It is, and it's not because they're being careless. It's a structural feature of how these systems are built. Which brings us to this concept of hidden layers, because that's really where the mystery lives.
Okay, hidden layers. I've heard this term thrown around. What are we actually talking about?
So in a neural network, you have an input layer, that's the data going in, and an output layer, that's the decision or prediction coming out. Hidden layers are everything in between. They're intermediate processing layers where the raw data gets transformed, step by step, into something the model can use to make a decision.
And they're called hidden because...
Not because anyone's hiding them on purpose, which is a common misconception. They're called hidden because they operate in that middle ground, invisible to the outside observer. The name is almost poetic, honestly. Raw data goes in, intelligent decisions come out, and in between is this zone that nobody can fully see into.
Okay, and how deep does this go? Like, how many of these hidden layers are we talking about in a modern AI system?
Deep learning got its name because researchers started stacking multiple hidden layers, sometimes 10, sometimes 1,000 or more. And the scale is staggering. According to the decoder, GPT-4 has an estimated 1.76 trillion parameters spread across hundreds of hidden layers. Each of those parameters is a tiny mathematical weight, and they all interact with each other in ways that are incredibly difficult to untangle.
1.76 trillion. I don't even know how to hold that number in my head.
Right? And here's what makes it even more concrete. According to McKinsey data cited in a 2026 guide on hidden layers power 96% of Fortune 500 AI applications. We're talking fraud detection, medical imaging, recommendation systems. This isn't niche tech, it's everywhere.
So the same architecture that makes these systems so powerful is also what makes them so hard to understand.
That's exactly the tension. Palo Alto Networks describes it really well. Deep learning systems operate in high-dimensional spaces, encoding patterns across thousands of parameters that interact in ways humans can't easily disentangle. Neurons carry overlapping roles, features blend together. It's not like a spreadsheet where you can just look at the formula.
So there's a spectrum here, right? Not all AI is equally opaque? Exactly. The AI Safety Directory's 2026 guide on interpretability lays this out really clearly. At one end of the spectrum, you have fully transparent models, things like decision trees or linear regression, where you can literally read the logic. You can see every step. At the other end, you have large neural networks where decisions emerge from complex interactions among millions or billions of parameters. Most modern AI falls toward that opaque end.
And there's a distinction between interpretability and explainability, right? Those aren't the same thing. Good catch. Interpretability is about whether you can understand the model's decision-making process as it's happening, like, can you inspect it in real time? Explainability is more about generating a human-understandable explanation after the fact. So a decision tree is inherently interpretable. A deep neural network isn't, but you can use post hoc techniques to try to explain individual predictions.
Post hoc meaning after the decision is already made.
Exactly. You're essentially reverse engineering an explanation. And there's a whole field called XAI, explainable artificial intelligence, dedicated to developing these techniques. Things like SHAP, LIME, attention mechanisms, counterfactuals. These are tools researchers use to try to shed light on what's happening inside the black box.
Okay, so now I want to get into why this actually matters. Because I think some people might hear the AI can't explain itself and think, well, as long as it gets the right answer, who cares?
That's the question, and Stanford's Graduate School of Business addresses it head on. They point out that AI is now being used to make choices that impact people's lives, reviewing loan applications, assigning hospital beds to patients, screening job candidates for interviews. And here's the key insight. Even if the AI makes a reasonable choice, if it can't explain why it made that choice, people may suspect it's biased or just plain wrong.
And that suspicion isn't unfounded, right? Because the opacity can actually hide real problems.
Completely. IBM flags this directly. The opacity of a black box model can hide cybersecurity vulnerabilities, biases, privacy violations, and other problems. And Palo Alto Networks takes it even further, arguing that black box behavior today is not just an interpretability problem, it's a security issue, a reliability issue, and a governance issue all at once.
That framing is really striking. It's not just we don't understand it, it's we can't audit it, we can't secure it, we can't govern it.
Right. And the ethical dimension is significant too. A paper published in the Journal of Computer Science and Systems Biology out of the University of Calgary points out that neural networks can inadvertently perpetuate biases present in their training data. This can result in discriminatory outcomes, biased hiring processes, unfair loan approvals, unjust criminal sentencing. These aren't hypothetical scenarios.
And the scale of the problem is enormous. Like, how many of these systems are actually explainable right now?
This is the number that really lands for me. According to the Glacis AI Explainability Guide from 2026, 85% of consumers want explanations when AI affects them. And yet, 60% of production models remain unexplainable black boxes. That gap is massive.
Wait, 85% of people want an explanation and 60% of the systems literally cannot provide one?
That's the reality right now. And Glacis is clear that this isn't just a user experience problem, it's a compliance risk, a trust risk, and an operational risk. Organizations that treat explainability as a post-deployment checklist item face higher failure rates and costlier rework.
So you can't just bolt on transparency at the end. You have to build it in from the start.
That's the key finding from Glacis. Explainability must be designed into AI systems from the beginning, with techniques chosen based on regulatory requirements, user needs, and acceptable performance trade-offs. It's not an afterthought.
And there's something interesting here about the relationship between transparency and trust, because I'd assume more transparency always equals more trust. But that's not quite right, is it?
This is one of the more counterintuitive findings in the research. A study published in MDPI's Behavioral Sciences Journal, researchers at Chongqing University of Posts and Telecommunications looked at how AI decision-making transparency affects employee trust. And what they found was that transparency increased both trust and discomfort simultaneously.
Both at the same time? How does that work?
So when employees could see how the AI was making decisions, they perceived it as more effective, which built trust. But seeing the inner workings also made them uncomfortable, which inhibited trust. These two effects ran in parallel. The researchers called it a parallel multiple mediating effect, and it helps explain why previous studies on AI transparency and trust had such inconsistent results.
So transparency is necessary but not sufficient. You can't just open the hood and expect everyone to feel great about what they see.
Exactly. And this is why how you communicate AI decisions matters just as much as whether you can explain them at all. The Glacis Guide has an entire section on communicating explanations, because the technical ability to generate an explanation and the human ability to understand and accept it are two very different things.
Let's talk about the regulatory side of this, because governments are clearly starting to pay attention.
Yeah, and it's moving fast. There are a few key pieces here. GDPR Article 22 already mandates explanations for automated decisions in Europe. That's been on the books. Then the EU AI Act requires transparency documentation specifically for high-risk AI systems. The original deadline was August 2026, though there's a provisional agreement to push standalone high-risk obligations to December 2027.
And what counts as high risk in that context?
Think healthcare, hiring, criminal justice, financial decisions. exactly the domains where the black box problem is most consequential. And in the US, Colorado has actually repealed and replaced its 2024 AI Act with SB 26-189, which requires deployers of covered automated decision-making technology to disclose how it informs decisions. That kicks in January 1, 2027, according to Glacis.
So the regulatory pressure is real, and it's coming from multiple directions.
And it's forcing the industry to take this seriously in a way that voluntary best practices never quite did. When there's a compliance deadline attached, the conversation changes.
Now, I want to go back to the technical side for a second, because you mentioned XAI techniques earlier, SHAP, LIME. Can you give us a sense of what those actually do? Like, what does it look like when you try to explain an AI decision?
Sure. So take SHAP, it stands for Shapely Additive Explanations. What it does is assign importance scores to each input feature for a given prediction. So if an AI denies your loan application, SHAP can tell you something like, your credit score contributed this much to the decision, your income contributed this much, your debt to income ratio contributed this much. It's not perfect, but it gives you a window into the reasoning.
So it's like a receipt for the decision.
That's a great way to put it. Lime works similarly but takes a slightly different approach. It builds a simpler, interpretable model locally around a specific prediction to approximate what the complex model is doing in that neighborhood. And then counterfactuals are interesting because they answer the question, what would need to change for a different outcome? So instead of just explaining why you were denied, it tells you what would have gotten you approved.
That counterfactual approach feels really actionable. Like that's information you can actually do something with.
Exactly. And that's the direction the field is moving, toward explanations that are not just technically accurate, but actually useful to the person receiving them.
The AI Safety Directory's 2026 Guide on Interpretability also highlights mechanistic interpretability as a growing area, which is about understanding neural networks from the inside, not just explaining outputs, but actually mapping what's happening in the hidden layers themselves. Is that actually achievable, though? Like, can we really get inside those 1.76 trillion parameters?
It's an open question, and there's actually a paper in Nature's NPJ Artificial Intelligence Journal that argues the field of XAI itself needs scrutiny, that popular methods need more formalization before we can really trust the explanations they generate. So even the tools we're using to solve the black box problem have their own transparency issues.
Oh, that's a bit of a recursive problem, isn't it? The explainability tools need to be explained.
It really is. And a survey published in MDPI's Electronics Journal by researchers from the University of Porto and INESC Tech makes this point. There's no consensus yet on how to assess the quality of an explanation. Which metrics do you use? How do you know if an explanation is actually good? These are still open research questions.
So we're in this moment where the demand for explainability is surging, regulations are tightening, but the science of how to actually do it well is still catching up.
That's a really accurate summary of where we are. And a CSIRO research review published in Applied Sciences in 2024 adds another layer. They found a notable preference shift in the field toward data-driven approaches to interpretability, which is promising, but also means the landscape of techniques is evolving quickly. What's considered best practice today might look different in 2 years.
And in the meantime, real decisions are being made by systems that can't explain themselves. That's the uncomfortable reality. It is. And the research on hidden layers from RMIT University, published in PMC in 2025, makes a point that I think is underappreciated. There's been limited research on actually mapping input features to neural network weights to understand how features are represented inside the layers. We're still in early days of truly understanding what's happening in there.
So when you step back from all of this, the scale of the problem, the regulatory pressure, the technical challenges, what does this really come down to for people whose lives are being shaped by these systems? Here's what I keep coming back to. The black box problem isn't just a technical puzzle for researchers to solve in a lab. It's a question of accountability. When an AI denies your mortgage application, or flags you as a high-risk patient, or screens you out of a job, you have a right to understand why. And right now, in 60% of cases, that explanation simply doesn't exist.
And the people most affected by these decisions are often the ones with the least power to push back.
Exactly. The University of Calgary paper on neural network ethics puts it plainly. Discriminatory outcomes from biased AI can affect hiring, loan approvals, criminal sentencing. These aren't edge cases. And the opacity of the system makes it harder to even identify when something has gone wrong, let alone fix it.
So the stakes are high, and the gap between what people expect and what systems can deliver is still enormous.
That 85-60 gap from Glasses is the number I'd want everyone to remember. 85% of people want an explanation. 60% of systems can't give one. That's not a small misalignment, that's a fundamental mismatch between what AI is doing in the world and what the world can actually hold it accountable for.
And the regulatory deadlines, GDPR, the EU AI Act, Colorado's SB 26-189, those are forcing the issue in a way that voluntary commitments never did.
Right. And the key insight from Glasses is that this can't be fixed after the fact. Explainability has to be designed in from day one, which means the organizations building these systems need to make a choice up front. Do we optimize purely for performance, or do we build in the transparency that accountability requires? And increasingly, they won't have a choice.
There's something almost hopeful in that, actually. The pressure is building from multiple directions: regulators, researchers, consumers, and it's forcing a reckoning.
And the tools are getting better. SHAP, LIME, counterfactuals, mechanistic interpretability, these are real advances. The field is moving. It's just moving against a backdrop of AI deployment that's moving even faster. The challenge is closing that gap before the consequences of opacity become irreversible.
Here's what this really comes down to, I think. We started this episode with the idea that an AI might be making decisions about your life right now, your loan, your job, your hospital bed, and nobody can fully explain why. And what we've learned is that this isn't a bug that's about to be patched. It's a structural feature of how the most powerful AI systems are built.
And the response to that can't just be trust the output. The whole point of accountability is that trust has to be earned through transparency. When 85% of people want an explanation and 60% of systems can't provide one, that's not a gap you can paper over with good intentions.
And the regulatory frameworks, GDPR, the EU AI Act, Colorado's new law, those are the mechanisms society is building to force that accountability. They're imperfect and they're still evolving, but they represent a real shift in how we're thinking about AI governance.
What I'd want listeners to take away is this: the black box problem is solvable, but only if we treat explainability as a design requirement, not an afterthought. The research is clear on that. Organizations that bolt it on at the end face higher failure rates. The ones that build it in from the start are the ones that will actually earn trust and stay compliant.
And for the rest of us, the people on the receiving end of these decisions, knowing that this problem exists is actually the first step. Because you can't advocate for your right to an explanation if you don't know you're supposed to have one.
That's exactly it. GDPR, Article 22, gives people in Europe a legal right to explanation for automated decisions. Colorado's new law is building something similar in the US. These rights exist or are being created, but they only matter if people know to invoke them.
So the next time an algorithm makes a decision that affects your life, and it will, you now know what's happening behind that curtain. Or, more precisely, you know what's not happening. A clear, auditable, human-understandable explanation. And you know that the push to change that is real, it's urgent, and it's coming from researchers, regulators, and the 85% of people who are done just accepting the output without the reasoning. That's the AI behind the curtain.
Thanks for listening to Copilot Podcasts.